Welcome back everyone to the Hello World guys. This is another episode of the Raycasting series, and in this video we are going to implement some collision detection for our sprites or the actual things in the game world. So if I run make, you know that we have got collision detection against walls working. We can collide against walls, we cannot pass through them, but earlier on the collision detection with the sprites was not there, and we could just move through the sprites, which is not of course what we want. So now we are going to implement it so that we actually collide with the sprite. So you can see if I go here, now I can actually collide with this box here, and I can also collide with this pillar here. However, this light, I have disabled the collision for this so that I can just pass through it without actually colliding. And you can see that this works quite well, and this permits us to have collisions for in-game objects as well. So that would be very, of course, a very useful feature if we actually want to make a game. We don't want the player to be able to pass through enemies or any other thing of that sort. We want the player to only be able to pass through where there is nothing or some particular sprite. For example, we should be able to pass through this sprite because the lamp is up top. It should not collide with the player. However, this pillar is something that should collide. So anyways, now let's look at the implementation. So first things first, I have made a couple of important changes. The most important one, well, it's not really that important. It is that I have changed the thing class here. So inside of this thing class, we don't just have a we don't call it, we have made it called thing instead of sprite. So it's essentially just a renamed class. I have renamed thing to sprite, and the only reason I have done that is because it's now not just representing a sprite that is displayed on the screen. It's representing an actual object in the game world, so this makes more sense for a name. You could also call it game object or something, whatever. And this has got a constructor now, and apart from the properties of the position and the texture which existed before, we have also got a float size here. So this, it actually represents like the collision size of the object, and this will be very useful, so we can specify things with specific sizes. And another change that I have made inside of editor and also renderer is that now we have removed the initialization function, and instead we use constructors for that because well, that's just better. We should follow RAIA principles, so we don't actually use any constructors for the we don't use initialization functions, we just use constructors. So apart from that, we can go ahead and you can see that we initialize everything here: player, renderer, editor, and map. We don't have to call init for any of them. And now you can see that we have got our things vector. We have earlier we just had a vector of sprites. Now we have actually got a vector of shared pointer of things. So the reason we have made this shared pointer is because we are going to have to keep references to our things in different ways. We might have references to things for a lot of different things might have represent references to other things, and if we make them in a vector, they will get rearranged, and they might get moved to other locations. So if a vector is resized, they might get reallocated, and that would mean of course that the earlier references would be invalidated. So for that we just use pointers, and raw pointers are pretty bad, so we use shared pointers instead. Here you could use unique pointer, I guess, but shared pointer just makes a lot more sense. And the next thing is that you can see that we loop over these things. We will understand this loop why we are looping over in a second. And one of the other things that have changed is that now we also draw the things here. So we create a rectangle shape, we set its color to green. When we are drawing our 2D view, we basically loop over the things and we draw them as well. This is quite similar to how we draw the players. There is nothing really that complicated here, but now we can go under the 2D view, and you can see we can see the things here, and we can only see the things that we are actually colliding against, because the things that we are not colliding against have a size of 0. So you can see that if I go to the array that we are creating here, the vector, you can see that we have got this here which has a size of 0.5. This is the actual, I think, the barrel, and this is the the other thing which we, the pillar, and this is the light which has got a size, as you can see, of 0, which means it doesn't collide. We cannot collide with it, and it also doesn't show up on the screen because it has a size of 0. But these things do show up because they have got non-zero sizes, and we can also collide with those. So that's pretty awesome. Now let's go here, and apart from that, the only other thing that we are going to have to change is that if I actually go ahead and open up my map.h, so in here we have made some drastic changes. Now the thing is that it won't be too difficult to write, because our player is an AABB and so are the things. It won't be too difficult to write a function for collision between them. The real problem that arises is the fact that well, just having a function that collides against things won't work, because we might have hundreds or even thousands of things in our map. So let's assume that we have got 500 things inside of our map, and it would be very wasteful if the player checked collision against each one of those things. That would be very bad. So it would be terrible for performance. But instead, what we want to do is we want to only check against the things that we actually can collide against. So if I'm standing here, there is no way I can collide with any of the sprites over there. So if I move to the left, there is absolutely no chance that I will collide there. So it's completely futile to actually check a collision against those. So to fix this problem, what we use is we use a block map. So if I go here, you can see that we have got a vector here. So we have basically got a vector of vector, just like we had for the grid. So this is essentially just a one-to-one replication of the map's grid here, called the block map. However, instead of containing an array of integers or something, it actually contains a set of thing pointers. So the idea is that the block map is just like the map grid. So it's basically the whole map grid, and each cell of those grid consists a set of pointers. So we use set because each element must be unique, so we use set for that. And this is essentially represents a set of pointers, and the reason that we use this is because well, it will be used by our player checking code. So when we are moving into a particular grid cell, we get the block map for that cell, and then we only check collision against the sprites that are in that cell. So if I'm moving forward right now, I'm not actually checking for collision against any of these sprites. But if I actually enter this grid cell, then I will start to check collision against this sprite. So this will be very useful for optimization. And inside of map.a, you can see we have got two new functions here. One is insert in block map, which we can pass it a map x and y coordinates and a thing pointer, and it will insert it inside of the block map. And we have also got a function for getting the block map, which will be used when we are actually testing. So if I open up map.cpp, you can see it's not really that complicated. I have kind of rearranged the functions a bit, and if I go here, you can see that we just ensured that the x and y are within bounds, and if they are, then we insert it in the thing into the block map. And when we are getting the block map, we just check if they are within bounds, we return the block map, and if they are not, we just return an empty set. And one more thing is that when we are loading, we need to make sure that we set our block map to the correct size as well. The set must be empty, however, it must be set to the correct size. And similarly, when we are saving, we don't actually save the block map, because we'll just rebuild it whenever we need it. And also another thing is that inside of here, when we are resizing our map, so we had a resize function here, we also need to make sure we resize the block map, and we resize the block map width as well, so each column of the block map as well, because the block map must be the same size as the grid. So yeah, that's pretty much it. This will present our block map, and it will be used to optimize the actual collision detection. So that's pretty awesome. Now I'm going to actually open up render.c, because here I have added a useful thing which can be nice, I guess. And we have got include stdi rotate here for some reason. I'm going to remove that. And you can see that we have got all of the things here that we had earlier. You know, we were drawing everything, but when we are drawing the sprites at the very end, what I have done is that I have also added two new variables here. One is size start and one is size end, and these are basically the same as draw start and draw end. However, the actual sprite size is first of all multiplied by the thing size, and the reason we do that is because this will kind of help us to debug the actual collision of the sprites. So when we are drawing the columns, if we are at the start or the end, we also draw a column of like green color here, which represents the starting or ending of the actual sprite's collision. So we append that into a separate vertex array. So you can see where we have got this vertex array sprite columns, we have also got a debug columns vertex array, and we insert it into that, and in the end we just draw it. I've commented it out because I don't really need to debug the sprites right now, but if I add that back, what you can see is that we get the collision detection. You can see that this is just a single line because it has a size of 0. However, these are displaying the correct sizes that are being used for the collision, because the reason is that of course we are not going to use the whole sprite because most of the sprite is transparent. So we, for different things, we'll have different collision sizes, and this can be a useful way to kind of debug those and see if we have got the correct sizes. Anyways, we don't need that right now, so I'm going to remove it, comment that out. We can turn it on whenever we need it. Now that is all of the basic stuff. So now if I go back to main.cpp, you can see we have got a for loop which goes over each of the things, and what it does is that it calculates the half size of the thing by taking thing size divided by 2, and then it gets the starting and ending point of the thing, much like we were doing in the player, by subtracting and adding the half size respectively. And then we loop over the starting and the ending x and y coordinates, and we insert it into the block map. So this means that we insert this thing pointer into each cell of the block map that this thing is intersecting with, so that this will initialize the block map correctly. And of course we will actually need to update the block map if we want to have moving things, but currently everything is static, so when we actually implement moving things we'll figure that out later. But for now this will initialize the block map with the correct values, and all that's left to do is to actually check for the collisions correctly. So I'm going to open up player.cpp where we are actually doing the collision. So if I go to the check map collision function, this is the function that actually does the collision. So in here you can see that if our map cell is if it returns true, then we just return true, and otherwise we go ahead and check for collision against the actual sprites. So now let's try to understand how this works. So the first thing we do is that we actually one of the things that we change is that these are now vector to f and not vector to I. The reason is that we need to actually use the floating point coordinates when checking against the sprites, so we just use the vector to f here, but when we are creating the for loop, of course we use integers. Those automatically get truncated, but the vectors are actually floating point. So here we first of all use map.getBlockMap to get the block map for the current position. Just like we were doing get map cell, we use get block map in pretty much the same way. And then we loop over each thing in that set. And what we do is, if the size of the thing is 0, then we don't really need to do the rest of the calculations. It means the thing should not collide, so we just continue. Otherwise, we first of all calculate the half size of the thing, and then we calculate the thing start and the things end vectors, and then we basically use a simplified version of the raycasting against AABB formula. So for that we get the player x coordinate, then we get the player's y starting coordinate and the player's y ending coordinate, and then we get the magnitude of the ray, which is just the ending minus the starting coordinate, and then we get two variables t1 and t2. Now these represent the points where the ray, it's not really a ray, it's a line, which is the line of the player that we are checking, and we get the 2 points where it intersects the the actual value of the player. So what we do is intersect the thing that we are checking against. So for that we get the thing start y position and subtract the player's starting y position from it and divide that by the magnitude, and for t2 we get the thing's end y position and subtract that and divide that. And this is just a simplified version of the standard raycasting formula kind of, and then we get the entry and the exit. So the entry is just the smaller of these values, while the exit is obviously the larger of these values, and whether we get an intersection on the y-axis or not, and this by the way is only for the y-axis. On the x-axis we are, when checking against the x-axis, for x we can just go ahead and check if the player x is greater than the thing start x and the player x is less than the thing's end x. However, for the y it will actually be a bit different because we are actually looping over the y here and a bunch of other stuff, so we need to make sure that that is correct. So anyways, what we do is we for the actually checking the y intersection, we check if our exit is greater than the entry and our exit is greater than 0 and our entry is less than 1. If all of these conditions are satisfied, that means that we did get an intersection on the y-axis. So this is for the intersection on the x. If that's true and the y intersection is also true, then we return true. Otherwise we just continue going over things until we get to the end. And for the y-axis, as you might imagine, it's basically the same thing but opposite. So we use the py here, which we set to new position.y. Then we use px for the actual checking. So when we are casting the ray, we use the x-axis instead of the y-axis, and we get x intersect here, and for the we use that formula for checking against the y-axis now. So it's basically the same thing, but the axes have been reversed, and that is pretty much all we need to do to check for collisions. And as you can see, that makes it work quite well. We can move around, we can collide with these, and these are implemented as AABBs. Perhaps it will be better to implement them as spheres. That might be a bit better. Anyways, let me know your thoughts about that in the comments, and I'll see you in the next video, in which we are going to try to make our things a bit more better by allowing movement for things, and of course we need to update the block map as well. And also we are going to turn the player into a thing, because the player is also essentially just a thing with some special attributes. So anyways guys, I'll see you in the next video. Make sure to like and subscribe and stay tuned for that, and share this video with other people as well, and bye.